The high stakes of engineering, why cost matters. Engineering projects are expensive. From skyscrapers that touch the clouds to bridges that span vast rivers, these feats of engineering require a huge amount of resources. Getting the cost wrong can mean the difference between a project's success and its failure. Imagine starting a major construction project without a clear picture of the cost. You might run out of money halfway through, leaving a half-finished building and a mountain of debt. This is where accurate cost estimation comes in. Cost estimation is like creating a financial roadmap for a project. It helps engineers and project managers make informed decisions from the very beginning. By understanding the potential costs, they can plan accordingly, secure funding, and ultimately deliver projects on time and within budget. Without this careful financial planning, even the most brilliant engineering designs can crumble under the weight of unforeseen expenses. That's why cost estimation is an essential skill for any engineer. Decoding the blueprint. What are engineering cost estimation models? Engineering cost estimation models are simply tools that help engineers predict the cost of a project. Think of them as mathematical formulas and techniques that consider various factors to provide a cost estimate. These factors can include things like materials, labor, equipment, and even inflation. These models are critical because they introduce a level of accuracy and consistency to the often complex process of estimating costs. Instead of relying on guesswork or experience alone, engineers can use these models to make more informed decisions. There are many different types of cost estimation models, each with its own strengths and weaknesses. Some models are simple and easy to use, while others are more complex and require specialized software. Choosing the right model depends on factors like the complexity of the project, the available data, and the desired level of accuracy. No matter which model is used, the goal is always the same: to provide a reliable estimate of the total project cost. This allows for better planning, budgeting, and decision-making throughout the entire project lifecycle. Tools of the trade popular engineering cost models. Let's look at 3 common cost estimation models used in engineering. Analogous estimating. This model draws upon the cost of past similar projects to estimate the cost of a new one. It's like saying, if building a 10-mile road cost X, then building a 15-mile road should cost approximately Y. This approach is quick and easy, but relies heavily on having accurate data from previous projects. Parametric estimating. This model uses mathematical relationships between project parameters like size, complexity, or duration and cost. For example, if you know the square footage of a building and the average cost per square foot, you can estimate the total construction cost. Parametric estimating is more accurate than analogous estimating but requires more detailed data. Bottom-up estimating. As the name suggests, this model breaks down a project into its smallest components and estimates the cost of each one. These individual costs are then added together to determine the total project cost. This method is the most accurate of the 3 but also the most time-consuming. Each model has its own place in the world of engineering cost estimation. The best model for a particular project depends on the specific circumstances and the desired balance between speed, accuracy, and available resources. Bringing it all together, cost estimation in action. Imagine you're an engineer tasked with building a new bridge. Using the analogous estimating model, you might look at the cost of similar bridges built in recent years. This gives you a starting point for your estimate. Next, you could use parametric estimating to refine your estimate based on the specific characteristics of your bridge, like its length, width, and design complexity. Finally, you might use bottom-up estimating to determine the cost of individual components, such as the foundations, piers, and deck. By combining these methods, you can develop a comprehensive and reliable cost estimate for your bridge project. This allows you to secure adequate funding, manage resources effectively, and ultimately deliver a successful project that meets both its technical and financial objectives. In conclusion, mastering engineering cost estimation models is crucial for anyone involved in planning, executing, or managing engineering projects. By understanding the different models, their strengths and weaknesses, and how to apply them effectively, engineers can ensure that projects are completed on time, within budget, and to the highest standards.